Hi, grade 12s, and welcome to lesson 1 of Physical Sciences grade 12. And we're going to be dealing with momentum and impulse. Okay, for some revision, first we have to understand what Newton's second law is saying to us. So Newton's second law says that the resultant force acting on a body will cause the body to accelerate in the direction of the resultant force, with an acceleration of the body being directly proportional to the resultant force and inversely proportional to the mass of the body. And then also, Newton's third law says that if body A exerts a force on body B, then body B exerts a force of equal magnitude on body A, but in different or in opposite direction. Okay, then we come into momentum. So what is momentum? In this case, you're going to be dealing with, at this level, you're going to be dealing with linear momentum. When you continue with your studies, then you're going to see that there's actually more than one concept of momentum, which is the angular momentum. But that's a story for another day. So a linear momentum is a vector quantity equal to the product of the mass of a particle or particles and its velocity. Mathematically, it's P, which is what represents momentum. P is equals to m times v. Or the reason why we wanted to understand what Newton's second law of motion is saying is because F net, which is the force acting on an object, can be equals to a change in momentum divided by a change in time. Then we come into what we call a conservation of linear momentum. So conservation of linear momentum just says that the total momentum of an isolated system is constant. And the total momentum, that simply means that the total momentum before the collision is equals to the total momentum after the collision. So that just simply means that the change in momentum is just equals to zero. It's supposed to be equals to zero if linear momentum is conserved. Okay, in the conservation of linear momentum definition, we talked about something which is the isolated system. So what is an isolated system? So an isolated system is a physical configuration of particles that doesn't exchange any matter with its surroundings, and it's not subject to any force whose source is external to the system. So an isolated system is just a system where there is no source of external forces to the system, no effect whatsoever. Okay, then we have to understand, because we also talked about the total momentum before the collision and after the collision. So what is collisions? So in terms of collisions, we have we have two types of collisions: the elastic collision and the inelastic collision. Where the elastic collision is a collision whereby the total momentum and kinetic energy are conserved. So the total momentum before the collision is equal to the total momentum after the collision, and the total kinetic energy before the collision is also equal to the total kinetic energy after the collision. And then for inelastic collisions is where only the total momentum is conserved, but not the total kinetic energy. So the total momentum before the collision is equal to the total momentum after the collision, but the total kinetic energy before the collision is not equal to the total momentum the total kinetic energy after the collision. And you can see it by the first one on top is for elastic collisions. So we have a ball of mass m1 and a ball of mass m2, and then they are moving at v1 and v2. So when they collide, they separate. they separate. The other one turns back and then the other one turns back. So the total kinetic energy before is also the total kinetic energy after, and the total momentum before is also the total momentum after the collision. But for inelastic collision, let's say we have a ball and ball 1 and ball 2. Firstly, notice the size. The size of ball 1 is not equal to the size of ball 2. So that means that there may be a difference in masses. Okay. So as you can see, after the collision, after they collide, they just move together. So that simply means that the kinetic energy before the total kinetic energy before the collision cannot be equal to the total kinetic energy after the collision. Then we get into an impulse. So what is an impulse? So an impulse is the product of the net force and the time interval for which the force acts. So impulse is just equals to F net times the change in time, which is where the change in time is the time interval for which this force or this sum of forces act. Okay, and then when we continue, we study what we call the impulse momentum theory. So the impulse momentum theory just says that the impulse is equal to the change in momentum. Where did this come from? Remember, we defined momentum in terms of Newton's second law, where F net is equal to the change in momentum divided by change in time. When you multiply the change in time by the F net, what do you get? You get the impulse. What that means? It means that the impulse can also be equal to the change in momentum.